How long do you reckon it would take to print a TPU Speedbenchy? It's not the fastest material in the world after all, is it? We know that. An hour? 2 hours? 5mm per second, right? Wrong. Let's go. So this is 95A TPU. If you came from the other video about softer TPU, then welcome. If not, there are 2 videos out at roughly the same time, and they're both about TPU, but they're both different. They're both valuable. I would advise watching both. It's International TPU Week. It really is, because I have this video coming up too. But this video here is exclusively about 95A TPU. That is your common everyday TPU that you buy wherever, Amazon, anywhere. If it says it's 95A, then it's 95A. If it doesn't say it's 95A, it probably is 95A. It's sort of become the de facto standard for TPU. Printing it though used to be a hassle. I mean, it used to be a genuine hassle. So much so that I kind of became popular in the early days of the channel by making TPU tuning videos. Like this all-time great on how to stop your TPU printing like I should have called it that, but I didn't. And various other videos about TPU. It's 2024 though now, and most of us don't print on these ancient heaps of Bowden. After all, that is the problem. Bowden. It was a mistake. I'm referring to this tube that goes between the extruder and the nozzle. And that, coupled with terrible extruder design, they were doing their best at the time, but it was a terrible time to be printing TPU. But those days are gone. Or are they? What we've seen in the last few years of 3D printing is progressively faster machines overall, driven by the unavoidable Benchy arms race. If you want to sell a printer in 2024, it had better do a Benchy in less than 20 minutes, otherwise nobody's going to buy it. The 2018 Ender 3, for example, would have a PLA print speed of around 15 to 20mm per second. That would do a Benchy in about, what, an hour and a half? This translated into a flow rate of around 3 to 5 cubic millimeters per second. We talked about flow rate in the other video, so make sure you watch it. Between 2018 and now, things have got faster and faster, and I've taken default profile speeds for PLA, and as you can see, there's a clear upward trend in the graph. What you'd expect to see is a corresponding upward trend in the speeds of all filaments. However, that does not seem to be the case. I did the same thing and charted out the default TPU profile speeds where they existed, or in the historical cases where apparently we didn't do that, we didn't have TPU profile speeds. As you can see, they are not tracking PLA speeds. Not even close. In fact, that kind of looks a bit like a flat line. We can clearly see that TPU speeds have in fact changed very little since 2018 in most cases. If you look at the chart, you would think reasonably that TPU printing is just as slow as it was in 2018, and if you print using those default values, then it will be. Is this actually true? Are printers still just as bad at printing TPU as they were in 2018? That's what I wanted to find out. This is my completely made up on-the-spot test model. You've probably met it already. The core is printed at 100% infill, so it's sort of a way of testing visual quality, but also extrusion rate by weighing it and using the 100% infill. It also tests stringing. I needed it to also not use much filament because TPU isn't cheap, and I actually bought this stuff myself for a change. We have Sunlu TPU in 2 colours and eSun in snot green. And I have a bunch of printers to test this on, and they're all fitted with 0.4mm factory nozzles, and they're all set up to print default line heights and widths and stuff on default TPU profiles where available. Default at least until I start speeding them up. All the printers performed fine at their default rates. Of course they would. These default rates are Bowden era rates, and 95A TPU, it really doesn't pose a challenge. If any printer couldn't do that, then it would be out of the window. They're on the good end of Bowden era rates. It's really hard to effectively communicate flow rate to you because it's not something most of you are used to, so I'll translate on screen. 3mm³ per second. It sounds slow, but it's not. It's not so terrible. If you had that on an Ender 3, you'd probably be quite happy. I haven't seen anyone complaining now, except me, because it's too slow. 5mm³ per second is getting more like it. This translates to about whatever's on screen. it's a respectable speed. To be honest, if you printed that in PLA, it would be okay. 10mm³ per second, still fine on all test printers, even the Bamboo. I don't know why I'm picking on the Bamboo, maybe because it has a reverse Bowden tube. 15 is the upper limit on a V6 nozzle when printing PLA. So that was a hard limit for an Ender 3 or a Prusa in 2018 for PLA. You would never have got that in TPU either. I mean, definitely not. That would just be ridiculous. And now we're just sailing right past it with TPU. No problems here. 20? No problems either. 25? No problem. Can we beat that? Of course we can, but after we have a chat about the sponsor of this video, PCBWay. Did you know that PCBWay can manufacture PCBs for your projects? The hint is in the name. They can, and it's actually really simple, even if you haven't done it before. You can go to the order page, click the quick order link, like on screen, and upload your files, where most of the default settings will be fine, and you can choose the ones you want to change. This usually comes down to changing the colours and the silk screen, at least in my case. That's the important stuff. That's all there is to it. If I can do it, you can do it, unless you're admitting that I'm smarter than you. PCBWay can also manufacture things out of metal using fancy CNC machines, like they did for this, and I know I still haven't released that video. It's coming. They can also 3D print metal, which I might be trying out soon too for a mystery video. No spoilers. You should check out PCBWay and see for yourself. There's links in the description below, including a first-time user coupon. Thank you PCBWay for sponsoring this video. So a moment ago we printed TPU at 25mm³ per second on all test printers, and so far as I remember, none of them failed. 30 is kind of where most hot ends that aren't doing something special are not really able to keep up. 35 is the limit for a Volcano nozzle, traditionally on PLA, for reference. I have a mystery printer here in the results that I can't tell you about. Not yet. And this printer is really surprising me too. I wish I could tell you what it was. I did ask the company in question, and they said no, which seems like more of a reason to tell you. But this printer, it hit 30, and it's not an expensive printer. I would suggest you keep an eye out for the future review of this printer, because that is surprising. That's all I'm saying. I should point out that 30mm³ per second on a default profile, it lands somewhere around 300mm per second. 300 TPU. And the secret printer went higher. This though, this is the FLSun T1. The FLSun T1 thinks 30mm³ is some kind of joke. It decided to go up to 40mm³. I think it might have gone faster too. I think I was the one who chickened out first. I might have gone to 45, I can't remember. This is where I started thinking, how fast could a Benchy be with these kind of flow rates? So I present to you the 10-minute-ish TPU Benchy. I should add the caveat, this is important, just because you can doesn't mean you should, with regards to some of these very high flow rates. Many printers might be able to extrude the TPU at these speeds, but they can't necessarily put it in the right place, and of course the higher you go in terms of flow rate, the more you're risking chewing it up in your extruder, and some of these extruders are a bit of a pain to take apart. bit of extra info here as well to clarify the point of this video. The caveat from just now is fine, but the point of me seeing how far I can push TPU was to prove that extruders do not fail like they used to. As you gather, the quality isn't always great. This is nothing new. Do the same with PLA, or indeed any material, and you'll get the same behaviour. Mainly because you just can't cool at these silly speeds. And that's why the FL Sun T1 with its huge fan does so much better than, say, the Bamboo. But anyway, that's aside from the point. The actual point of the video was to show how far out of line the TPU defaults that we currently have in slicers are, and while most printers can go up to hundreds of millimeters per second, you want to be able to print neatly, and that can be achieved with double, triple, maybe even more times the current defaults on TPU. The point isn't specifically to make a TPU benchy. While that's fun, the point is we're all wasting a lot of time printing TPU generally still way too conservatively. Take for example this print that I've got on screen where I saved about 2/3 of the time, I think, I haven't worked it out exactly, over the default settings. I want people to make their own profiles, but I realise that some people don't want to do that, or they just don't want to understand the settings to the same kind of level that you would need to. I'm in the process of making some 3MFs with settings that are more sensible for TPU. I'll share those over on Patreon as I do them. These are more likely to be just generally faster print settings, more like the ones you'll use for PLA normally. I did mention I would check the weights of these test prints as well, so those are on screen. So what are we supposed to even think about all this? We started with the discovery that every printer's default profile seems to be slowers, and we've discovered that the reality with these modern printers is that they can print TPU almost across the spectrum at almost, or in some cases actually the same speed as PLA. I suppose the question is, why? Well, there's two why questions. The first question is, why can they do this? Why can printers print that fast now? And I think the answer is quite weird. Think about this. If you have a modern printer and you print PLA, when was the last time you had to open up the extruder to service it in any way, to remove trapped filament, or to clear a blockage, to do a cold pull? Most extruders in the last year or so have gotten a lot more reliable. If you run a Bamboo, there's a non-negligible chance you may not even know what the extruder looks like. I personally have never had to take one apart. Extruder design is a whole thing now. Compared to this from a few years ago, we are massively different. These two things are kind of unrecognisable from each other. The second why question, and this is almost more important, why are manufacturers not speeding up their TPU profiles? Now, I honestly don't know. My best guess is because TPU is a fickle material and they might be too risk averse. After all, if it's not going into the marketing copy, if you're not selling the printer based on a TPU speed, why would you bother spending time trying to tune it? Just get it working. So there is a conclusion here, I think. The conclusion is to demand more of manufacturers when it comes to TPU. I personally want to see more people asking how fast a new printer can do a TPU benchy. I'm fed up of seeing PLA benchies, and I'm sure you are too. Oh, and I suppose the other conclusion is just to get a bit more adventurous with your own TPU speeds. It is not 2018 anymore, just try going a bit faster. And with that, thank you for watching.